Alright, these are the Lesson 13 2 notes day 1 on angles in the unit circle. Today we're going to find measures of angles in standard position. We're also going to be able to calculate sines and cosines of angles on the unit circle. First of all, we're going to talk about measuring on a circle, and we're going to find some measures of angles in standard position. When you're measuring angles, there's two options. One is to measure an angle if we consider 0 degrees to be right along this right side of this horizontal axis here. If you measure angles going in a counterclockwise direction, that's considered to be a positive direction, going this way. So this angle here would be measured as 60 degrees. Now, if you decide to measure the same angle but going in a clockwise direction, clockwise angles are measured as negative angles. So the same angle, if you go the other direction, is going to be measured as negative 300 degrees. And if you put the 60 and the 300 together, there's 360 degrees, which make up a circle. So if you start at 0 and go in the counterclockwise direction, that's considered to be a positive angle. If you go in the clockwise direction, that's considered to be a negative angle. Now 60 degrees and negative 300 degrees are both referring to basically a measurement that's formed by this horizontal line here and this ray that's pointing up in this direction. So we say that negative 300 degrees and 60 degrees are coterminal angles. Coterminal angles are angles that basically have equal end locations. And obviously an example of this would be positive 60 degrees and negative 300 degrees. And one way that you can identify these types of angles, if we use your calculator, is if we start at 60 degrees and take away 360, which is a full circle, you will get negative 300. That's a coterminal angle. And if you continue to subtract 360 degrees, you will continue to come up with more coterminal angles, like negative 660, negative 1020, and negative 1380. Likewise, if you continue to add 360 to your angle, you'll also get coterminal angles, like negative 300, 60 degrees, 420 degrees, 780 degrees, 1140 degrees, etc. Now what we're going to do next is we're going to take a look at problems 1 and 2 below, and we're going to find the measure of angles in standard position. You'll notice in problem number 1 we have a 60 degree angle that's formed by this vertical axis as well as this ray that's shooting out here. Now when we measure an angle in standard position, we always start at kind of our 0, which is this horizontal right here. And we're measuring this arc, which is going in a counterclockwise direction. Now you may recall, if we're going in a counterclockwise direction, this is going to be a positive angle that we're going to measure. So how many degrees is this angle? Well, as you move around this grid here in a counterclockwise direction, our first notch here, our first kind of vertical axis here, is at 90 degrees. You can see there's a right angle that's formed there. If we go halfway around the circle, we know that's 180. If we go 3/4 of the way around the circle, you add another 90 to 180 and you get 270. Now we're looking for this measurement right here. So we're going 90 degrees, which makes up kind of this first part, plus an additional 60 right here. So really we need to just add the 60 and 90 together. And when you do that, you get 150 degrees. It's positive because we've measured in a counterclockwise direction. So there's our solution, 150 degrees. What I'd like you to do is pause the video and see if you can figure out the measure of this angle that's measured from our starting point at 0 going this direction around the unit circle. See what you come up with, and we'll see what you get in just a moment. So in this example, we are traveling in a clockwise direction, going this direction, so our answer is going to be negative. If we travel from here to here, we've traveled 90 degrees. If we go halfway around the circle, that's 180. Now we've traveled 180 plus this little bit. What's this little bit? Well, it's not 60. 60 is this measurement right here. So this is sort of the leftover part. Between 180 and 270 is a total of 90 degrees. So this leftover piece here, 60 plus 30, is sort of what we're looking for. So this little space right here is going to be a 30 degree measurement. And if we take 90 plus 90 is 180 plus another 30, that's equal to 210 degrees. Because we've traveled in the negative direction, your answer should be negative 210 degrees. Now we've already talked about finding coterminal angles. What I would like you to do is see if you can figure out the answers for 3, 4, 5, and 6, finding positive and negative coterminal angles. Now one example that we looked at earlier was the example of 60 and negative 300. What we just found in this example is also coterminal angles because we're measuring basically to the same measurement, positive 150 and negative 210. They're 360 degrees apart. You may remember that you can do 150 minus 360 to come up with an example of a coterminal angle, negative 210. See if you can find positive and negative coterminal angles for problems 3 and 4. See if you can answer 5 and 6. Pause the video and we'll see what you get in just a moment. So for number 3, to find a positive coterminal angle, just add 360 degrees to 60. It will take you back around the circle, and when you do that, you get 420 degrees. That would be an example of an angle you could use. Likewise, if you're at 60 degrees and you take away 360, you could go back up to negative 300 degrees, and that would be a coterminal angle that's negative. Same idea for 250. If you add 360 degrees, you get 610 degrees. And if you're at 250 and you subtract 360 degrees, you get negative 110 degrees. If you're looking for an angle between 0 and 360 that's coterminal with negative 160, what you need to do is you just need to add 360 degrees until you get to a positive angle that's between 0 and 360. 200 degrees would certainly work here. Now it gets a little trickier when you're working with numbers that are maybe the thousands of degrees, for example 1060 degrees. To get this back to an angle that's between 0 and 360, subtracting 360 doesn't quite get you there. You may have to subtract 360 degrees numerous times until you get an angle that's between 0 and 360, like 340 degrees. As we move on here, we're going to take a look at values of sine and cosine on the unit circle. Now, sine and cosine may sound like familiar terms. If you've taken a little bit of trigonometry, we work with triangles in geometry class when we talk about sines and cosines of angles. We're going to look at sines and cosines on a circle today, and we're going to specifically look at something called the unit circle. The unit circle is a circle with a radius of 1. And it's called the unit circle because the prefix for the word unit, uni, does mean the number 1. So we're dealing with a circle similar to the one that you see at the bottom here of your paper. Now, on this particular circle, we're going to consider that this point right here is the point 1, 0. And that the point up here would be like the point 0, 1. So this is a circle that's centered at 0, 0 that has a radius of 1. For this example, we're going to talk about something called cosine, which is abbreviated COS. Cosine is the x-coordinate of the point at which the terminal side of the angle intersects the unit circle. Cosine is dealing with x. Sine, on the other hand, is the y-coordinate of the point at which the terminal side of the angle intersects the unit circle. Now this may sound like gibberish for right now, so let me explain a little bit better what we're talking about here. We're going to use your calculator to find values of cosine theta and sine theta when theta equals 120 degrees. Now anytime you work with sine and cosine on your calculator, the first thing you want to check is the mode. So we're going to go to your mode. We're going to make sure that we're working with degrees. You'll notice my angle is measured as 120 degrees. There's another way of measuring angles using radians, which we'll talk about later. But for today, we're working specifically with degrees, so make sure that degrees is highlighted on your calculator screen. To find cosine of theta, there is a cosine button. It's abbreviated COS. And all you have to do is type in 120 on your calculator and hit enter. The value you get is negative 0.5. So I'm going to make a note that the cosine of 120 degrees is equal to negative 0.5. I'm going to calculate the sine of 120 degrees in a similar method, touching the sine button, keying in 120, and I get this decimal 0.866. Now what we're going to do is we're going to sketch a 120 degree angle based on the values calculated in number 7. Negative 0.5 is my x-coordinate because it's a cosine value. 0.866 is a y value because it's a sine. So I'm going to graph the point negative 0.5, point 1, 2, 3, 4, 5, and we're going to go up to 0.866. Point 1, 2, 3, 4, 5, 6, 7, 8, 6, 6. Now it's interesting, it appears to be actually a point on the circle, which it should be. What this point represents is if you're to sketch a segment that goes back to 0, 0, and we'll make this into a ray, we had mentioned in the definition, cosine is the x-coordinate of the point at which the terminal side of the angle intersects the unit circle. So this angle that's formed by a 120 degree arc right here The cosine value is the x-coordinate where this point intersects the unit circle. And the sine of the angle, 0.866, is the y-coordinate of this point as well. So it's a neat little application that you can find involving sines and cosines on the unit circle.